Bismillah ar-Rahman ar-Rahim. October 24, 31 variant, complete pure paper we are going to solve. So get ready, students. Question number 1, polynomial, this is given, and a, b are constants, and p of x is denoted by. It is given that p of x is 2x plus 1 is a factor, and p of x divided by x minus 4, remainder is 3 times the remainder when divided by this. So first of all, we'll write p of x. Okay, he's saying 2x plus 1 is a factor. So factor whatever we plug in equal to 0 and get x value from here. 1 goes there and negative half. I replace whole equation, whole x, every x by negative half. So when I replace left side negative half and here negative half. So a lot of chance of mistakes. So that is why don't try to take a risk of direct working. Best way is plug in like this. And because of factor word, this equal to 0. Okay, and this is done, and this is 8, so we've got negative 1 over 2, and this is becoming with us positive a over 4, negative 5 over 2 plus b. Now 2 and 4, so we have a LCM into multiply into 4. So I get negative 2, I get a, I get 10, I got a 4b, and I'm getting equation a plus 4b is equals to 12. Equation number 1 done. So this is done, students. Now we are going to do another equation. And how to get that equation? We have to look carefully. X minus 4 is when we divide is a remainder that divide by x minus 4. It means P is, if I plug in x minus 4 equal to 0, students, it means we replace every x by 4. So P of 4 is 3 times the remainder when divided by x minus 2. So x minus 2 is equals to 0. We plug in x is equal to positive 2. So when I plug in positive 2, so we got this and 3 times. Why 3 times? Because he said that 3 times. So I'm going to start from here. But first of all, students, what I will do, I will replace 4 in a whole equation. So step number 1, I will copy whole equation, paste here, replace every x by 4. Then what I get, students, P of 4 into 4 to power 3 and 4 to power 2 and 5 times to 4 plus b. And I'm not doing anything with the P of 4. So here 4, it means 4 to power 4 is 256. And 4 to power 2, so I'm getting here 16a, 20 and plus b. And finally, I got it 276 plus 16a and plus b. I'm leaving it here. Now, students, first I plug in this one and now plug in 2 on whole equation. So once again, I need equation. All right, here. And this time I'm putting every equation, every x by 2. So when I put 2, students, 2 to power 3, 2 to power 2, and b. Okay. And P of 2 value is giving us 8 for the 32, 2 square 4a, and 2 5s are 10 plus b. And then I'm getting finally 42 plus 4a and plus b. And as he said, that condition number, the top mentioned here, this one. So P of 4 is equal to 3 times P of 2. So students, I'm going to plug in the values. So P of 4 is 276 plus 16a plus b. Okay, maybe we need a proper space, so I'm going down. So this value, students, come from here, equals to 3 times 2 P of 2, and this is a P of 2 basically, P of 2. Okay, so P of 2 is 42 plus 4A plus B. 3 multiply inside, 276 plus 16A plus B. And 3 to the 6, and 3 4s are 12. 12A and 3B. Okay, now student, what to do after this? I bring B on other side, I got a 2B. This goes other side, I got a negative 4A. And this goes other side, so 276 minus 126, 150. So I got second equation here, students. So I can, let me check upper equation. A is nothing. So I can divide by, and B is what coefficient? B is 2. So reorder 2B minus 4A is equals to 150. Okay, students. Now I'm going to do the here. A plus 4B is equals to 12. And this I'm copying here. And negative 4A plus 2B equal to 150. Now, students, what I can do, so multiply this equation with a negative 4. I'm getting negative 4A and negative 16B and negative 48. And negative 4, sorry, not negative, because student, I think, sign change already. So with a positive 4. So I'm getting 4A, 4 for 16B, and 48. This cancel out, I got 18B and 150 plus 48, 198. And divided by 18, I've got 11. B value is 11. And this value, students, I can plug in any one equation. I plug in the top equation better. So I plug in a top equation. So A plus 4 times to 11 is equal to 12. So A plus 44 is equal to 12. And A value 12 minus 44, we are getting negative 32. So I hope so, students. Idea is very clear, and a lot of patience required to solve this kind of question. And there is a plus B, A and B was target to achieve, and we have done it. Question number 2, students, we have, and topic is integration by parts. And the two functions are multiplying here. You can see clearly. And one is x square and one is a logarithm. But I will write in reorder form ln 3x before and x to power 2 later. Logic behind is very clear. L-A-T-E, late. I add down. I late. I am late. I stand for inverse function, students. L stand for logarithm. A stand for algebra, I mean x or x square. T stand for trigonometry, I mean sine or cos. And exponential e to power x or e to power 2x. Top to bottom, top is v, down is u. It means if exponential come with algebra, exponential is v function and algebra is u function. So now see the level, logarithm is below, algebra is above. That is why logarithm I have taken u function and algebra is taken as a v function. So u and v. Formula. Formula, what we have, uv formula, students. U copy integration of v minus a big sign of integral, bracket starts, bracket ends dx. Again, integration of v, I mean same, whatever done here, same copy paste, into differentiation of u. So let's try to apply, students. Okay, this I just drag slightly right side. Okay. Now applying u copy, I mean ln 3x copy into integration of x square minus a big sign of integral, bracket starts, ends, and dx. Again, integration of x square, multiply differentiation of ln 3x. So students, what is this? Is remains same. And what is x square integration? Increase a power by 1 and divide by same. Again, same thing, increase a power by same thing. I mean, what is done here, same, copy paste. And multiply derivative of this. What is the log differentiation, students? After in the logarithm function, whatever 3x will go directly in denominator without any change. And this derivative is 3 will come in numerator. That's it. So now, student, this 3 cancel out and x will cancel and become x square. And we got x to power 3 over 3 times to logarithm of 3x. And this 3 can come out. And what left inside? X squared dx. Now, students, I hope so the idea is clear, and now we can finish our question. Okay, easily. Okay, x cube, 1 minute, x cube over 3 logarithm of 3x and minus. And what is this integration, students? That is very clear, 103 as it is, x to power 3 over 3. And now I'm going to put limits. And what limits, students? 1 to 3. I simplify first and then I'll go for the limits. Otherwise, a risk is there and chance of mistake also there. I hope so, student, this is clear. And what is my job to plan to find it? He said, given this form and rational number and B is integer. C is rational number and A also rational number, but B is integer. All right. So have a look now. I'm going to plug in the values. First, I plug in the value 3 in each x value. So 3 to the power 3 is 27. 27 by 3 is 9. 3 3s are 9. I got log of 9. Now 3 plug in here. 3 to the power 3 is 27. And 9 3s are 27. Upper limit is done. Lower limit. When I plug in 1, each value, student, 1 by 3 times 2 logarithm of 3. And when I plug in 3, 1 over 9. This is done, students. Now we have to expand it and make sure those are, what is the 3 and what is it here? 9. 9 I can convert in special form. And what is that? 3 to power 2. And that 2 will come down later on. Here I'm leaving this as it is, no change, and negative into negative, positive 1 over 9. So student, 2 9s are 18 log of 3. And this I bring close to it, and negative and plus 1 by 9 and negative 3. Now students, what I can do from here, log of 3 common, what left inside 18 minus 1 over 3. Though this step is not compulsory, here LCM 9 and 1 minus 27. So 3, 8, 54. So 54, 53. 53 over 3 and logarithm of 3 and minus 26 over 9. And Alhamdulillah Rabbil Alameen, the job is done. But did he mention, give answer? He said only form. So it's not compulsory to give the answer of A, B, or C, whatever. And I hope so the concept is very clear. And question is, question number 3, students, equation of curve is given here and find out the gradient of the curve at this point. And gradient means differentiation. So let's start. Okay, what is the logarithm function? We have bracket according to criteria. If we have a logarithm function come, for example, x to power 2 plus 1, what we'll do, the whole thing goes in denominator, and this derivative comes here, and this derivative comes here. Same story here, students, I'm going to do. So x plus y will come in denominator because in the bracket, and x derivative is 1, and y differentiation is dy over dx is equals to, here product formula, I'm dealing 3x squared as a u and y as a v. So 3x squared copy and y derivative here, and now y copy and 3x squared derivative here. So y differentiation is dy over dx, and here 6x. My job is to find out a gradient. There are 2 dy dx, okay? Now I have 2 approaches. I can put directly x and y value here, or I can do after 1 or 2 steps. Maybe if I plug in x and y at this level, I think this is a bit easier. How easier? Look at here. He did not mention at all here to make a dy subject. Sometime he asks us to find out dy over dx or a special form. He did not mention here. Here it means I can plug in immediately, put x value 1 and y value 0. So when I plug in 1 and 0 here, so we can get rid of this easily. 1 plus dy over dx over 1. So that one you write or you don't write, no problem at all. So left hand side, you see it become very easy now. Let me write again. So left hand side, we got rid of x plus y from denominator. When I plug in 1, students, I'm getting 3 times 2 dy over dx. And when I apply 0, full 0, you see the question becomes very easy in this way. Okay, and after this, I will do what, student? This I'll bring on other side. 1 is equal to 3 dy over dx and minus dy over dx. And is a 1 number, 3 minus 1, we got a 2. So 1 equal to 2 dy over dx. And 2 divides. So Alhamdulillah Rabbil Alameen, I'm sure you understood very well. So it means gradient is half. So you have seen, students, here, if you plug in sometime, we plug in immediately in a question becomes very, very easy, and we have done it. Question number 4, students, we have show this identity equal to this one. So, students, a square minus b square property is applicable only two conditions when we have a two squares and negative sign in the middle. So we can say one time plus and one time minus. So before I just tell you one thing, sine square theta plus cos square theta is 1, is given in the formula sheet. If I divide by cos square, students, what I get here, tan square theta plus 1 equal to secant square theta. Okay, students, if I bring secant square on the tan square on the other side, so I get secant square theta minus tan square theta. This is a logic. This I will get from here and I will make it 1. So that is the reason I'm applying. Get ready. So first of all, I'm saying secant square theta whole square and tan square theta whole square. So one time I will add and one time subtract. So secant square theta plus tan square theta, and same with the negative sign, same with the negative sign. Okay, same with negative sign. I think this point is very clear. And change the sign. Okay. So now, student, you know it very well. Secant square theta minus 1 is giving 1. So I'm replacing it by 1. So I'm getting secant square theta plus tan square theta and times to 1 because this is a 1. This is 1. Okay. Now I got a secant square theta. What's my target to achieve this one? Look at here, though there's no secant square required. So it means secant square theta, first I'm writing, then I replace a value. And even this formula available with us. If I make a secant square, I have already subject available. So 1 plus tan square, I can replace it here. So 1 plus tan square I have to replace and question is done. So 1 plus 2 tan square theta. So right hand side proved. Okay, so this is done and now because it's A part, and let's see next part, B part. Same part you can use to and this is use here. So I must bring that previous proving part on this page, which will help us to solve. So secant 4 theta minus tan 4 theta is basically is equals to this. Okay, I have done it, this already. So this complete expression, this complete identity, I'm bringing on other page. It will help us to solve. So students, I'm writing now here. This is given. You can say this is given as we know, as we done as A part. So we can write what, student? Interesting part. Check it. What is a similarity here? Everything similar, only in the place of alpha, he is replacing 2 alpha. Sorry, in place of theta, he is replacing 2 alpha. And this is done as it is. Okay, what I'm going to do, students. So first of all, it means I can say simple. This right hand side, student, I'm writing as it is. So 2 tan square 2 alpha secant square 2 alpha. But left hand side, because match, I will replace by this one. So it means I will copy the whole thing here, 1 plus 2, but in the place of theta, I will replace 2 alpha. That's it. Reason, because see that theta replaced by 2 alpha. Not one complete question. Okay. Now that is by 2 alpha, 2 alpha, and 2 alpha. Now I have to solve it, students. Solve it and first two quadrant, because still 180 degree. So how we can do this, students? Now problem is with us is because tan secant together. If we go back to the previous page, we have a formula available with connecting secant with the tan. So secant square is 1 plus tan square, 1 plus tan square. So I can remove secant square and replace 1 plus tan square, 1 plus tan square. So there's some copying. Basically whole equation copy. This paste here, but in place of this one, I'm writing here 1 plus tan square. So student, now I can complete 2 ones are 2, 2 tan square, 2 alpha, and 2 tan square, tan 4, sorry, and 2 alpha. And here I got 1 plus 2 tan square 2 alpha. And let me check. Yes, I think I can see clearly. This is a total match. This is a total match. It can be cancelled automatically here like that. And I'm getting here 2 tan 4 double alpha is equals to 1. I can say tan 4 double alpha is equals to half. Now, you know, student, whenever power 4 comes, I taught many times, when power 2 comes equal to k, we can write plus and minus root of k. And when power 4 comes here, students, what is same story, but this time plus and minus and fourth root of k. So whenever even power, students, come, even power, plus and minus and fourth power, even power will come there. So I can say here, I got here tan double alpha is equals to 1 over 2 and fourth root and plus and minus. So one time, students, I'm writing here, and tan 2 alpha is equals to, I think up till here, point is clear. And so so student, what to do now? I'm writing one time positive and one time negative. So check it, 1 over 2 root, fourth root with a positive sign and negative sign. I think this part is very clear. And now, students, what I can do now, I can make it type, okay, this is a tan is positive is first quadrant and this one. Because double alpha, so that is why I will consider both angles. And tan negative is here and here. For a while, I take this alpha, sorry, x, or not x, I take as a beta, for example, and tan inverse of the whole thing. But I will type it one time only, because no need to type even second one, because remove the sign negative. So 1 over 2. And students, it is a degree mode, make sure. And so I have a fourth root of, so 1 minute please, 1 divided by 2. The power is fourth root. And now I take a tan inverse. My answer is coming with me is 40.1. 40.1 degree is coming from here. Okay, 40.1. Now, students, 40.1, I will take even here, 40.1 I'm writing, and 40.1 I'm writing here even. Not even here, student, other also, 40.1 and 40.1. Now, what is the rule of measurement? Start from positive x-axis, move anti-clockwise till 9. So this is the first answer and this is the second answer. And second one here, start from positive, and this is first answer and this is second answer. I'm going to find both one by one. So first of all, 2 alpha comes back from there on the top. And I'm writing first angle 40.1. Second is 180 plus that. So 180 plus. So when I say 180 plus, I'm getting here 220.1. And same story other way, students. So I'm writing 2 alpha. 2 alpha is equals to 180 minus 180, 180 minus 40.1 and 360 minus 40.1. So I'm going to find alpha for everywhere here. If I 40.1 divide by 2, I get here 20.1. 20.1, this is my first answer. Hold on, let me check again. 40.1 divided by 2, for basically it's coming 20.1 dp I'm looking for. So it is coming 0.1. Okay, second answer, 220.1 divided by 2, and I'm getting here 110.1. So third last, second last, minus 40.1, and this angle and divide by 2, I'm getting here 69. So alpha is becoming 69.695, and after rounding becomes 70 degree. And last, students, just wait, let me finish it. 40.1, and we subtract and divide by 2, I'm getting 159.160. So I got 4 answers, students. So I hope so. The concept of the question is very, very clear, and we have done the question. Question number 5, students, we have by sketching a suitable pair of graphs, show this equation has only one root. Okay, students, now sometimes student he mentioned here like starting from 0 till pi or pi by 2 or something like this, but it did not mention here. So whenever this condition comes, you will just see part number B or sometime part number C. We can judge from there that where the root lies between that. You can see that root lies between 7 and 9. And you know, if I check it, 2 pi is a 6 point something, okay? It means pi I will not consider at all. I will just take the numbers and I'll complete the question. How come? I can start my graph because the answer lies between 7 and 9, approximately 8 maybe, okay? So what I will do, student, I will start my sketching. I will not take too much, too many values because it's only for 2 marks. So that is why I'm going to have a look now. Okay. All right now. So what is the way, students? I'll just tell you what is method to do it. So no need to label. If you label only and you can erase later on or you leave it, no problem even. So here just compression, you show it or don't show compression even. Just mention here that 7, 8, 9. I think we have to start from 6, 7, 8, 9, 10. I think enough values to express, okay? And if you show the compression is good to show, but if you don't show compression, no problem. Now 6 value I'm going to place now. I'm using my calculator and I'm putting the values roughly, okay? And okay, there are 2 equations, student. One is left and one is right. So y is equal to 2 plus e to power negative 0.2x. And second equation is y is equals to logarithm of 1 plus x. I have 2 equations. Make sure there's no sine and no cos. And you know one thing, sine cos give you infinity sometimes. So now you can use your calculator. You can use a function of table function. And we can use it easily. Okay, I can show even my calculator even. So I use a mode function and table function available. Just I will show once only. Okay, for example, 2 plus exponential is this, and power is negative 0.2 times 2x, and x is this. So when I press equal sign, it will say start from where? I will say start from 6. So ends where? I'll say ends at ends at a 10. Step how much? Step is 1. So these values we are getting, you can see in clearly, okay, and I can show you the numbers. Okay, so problem is, wait a minute, decimals, I have to convert it. Yeah, wait a minute. I have to convert in decimals. This is a, okay, let me check it. Now, when I bring it in, it will give me decimal 2.3. What is the next number? 2.2. What's next number? 2.2. Next number 2.1. And next number 2.13. So student, in this way, you can make a table. You can use your table function and you sketch it. Okay. And I'm going to complete now. I'm going to complete now. Check it. And I check the sum numbers. Okay, this 2.3, and then next is a 2.2. So it means I just make it somewhere. I'm slightly here, sorry, 6, slightly up, and then it is coming slightly down. So basically, if you look at students, no need to show every point. You see this, the values are gradually reducing. It means this, I will show like this only. I'll show like this to examiner, because that your table function will tell you easily that this graph is shifting this way. So you go show this graph. If you show this graph, that's enough. Okay, no need to show too much, because 2 marks only, 1 mark for each graph, each sketching. So that is why this is enough. Okay, this is done. Now second graph, student, same manner. If I make it, okay, I use my table function and I do it now in quick time. And if I make it the other function, students, so it will start from here. It will start and it will intersect somewhere here, and it will become like that. Okay, so and no need to show in a depth, okay, because we have to show this one thing only, point intersection, and we have to mark it, okay, and that's it. And what to write last statement? Yes, 2 plus e to power negative 0.2x is equal to logarithm of 1 plus x has one root, only one root. Okay, now question comes, this intersection is if you show, okay, if you don't show, no problem at all. I think idea is very clear. So now next part, he's asking by calculation show this root lies between 7 and 9. How we can do, students? So take the expression, two choices, bring on the right hand side or bring this on the left hand side. Both are correct. So because x involves, students, so I'll write here f of x. Okay, now I'm going to use this complete and copy. I'm using here function as it is. Okay, now student, what to do? I brought this on the left side. Now I'm going to replace every x value by what? 7. Every x value by 7. Okay, and now I'm copying this whole equation because I will copy two values one by one. So that is why. So this is done, students. Now one time, students, I will plug in 7, 7, and 7. And one time put 9, 9, and 9. Okay, so now I'm going to check it in calculator in quick time. So what value I'm getting in the top equation and down equation. So first is 2 plus exponential to power negative 0.2 times to 7 and negative logarithm of and 1 plus 7. So I'm getting here positive answer 0.16 or 17. And if I replace every value by 9 now, so I'm going to check it. And I'm getting the answer negative, students, 0.14. And just simple rule, as sign changes, oh, sorry, I wrote sign 2 times, sign changes. So root lies between 7 and 9. See, these signs are changing. And I always give example, this one, to sake of understanding. So at 7, we have positive. So let's say this graph, and 7 is this, and 9 is this. At 7, we have a positive value, and at 9, we have a curve value as a negative. So this means this is a root. I hope so this part is very clear. And you understood that the root lies between this. Okay. So let's go for next page. Next page, he says use iterative formula. Iterative formula and and determine the root of two decimal places. Give each iteration 4 dp. Okay, and he said this is actually called like e to power x. Okay, now student, what to do? So first of all, I will replace every n by 1. So replace n1 here, n1 here. So I'm getting here x2 and e to power 2 plus, sorry, in the bracket, I'm writing here 2 plus, again e to power negative 0.2 into x1. So because I plug in 1 here, so x1 close bracket, and minus 1 is goes down. Okay, make sure, because this completely in the power, that is why I think this part is very clear. So students, what I'm going to do, and first of all, problem is that do we have a value, the initial value given or not? Sometime initial value given and sometime initial not given. If not given, go back and find out the average of these numbers. So 7 plus 9 divided by 2. So 7 plus 9, I divide by 2, I get an 8. So it means initial value I'm getting is 8. So I'm writing here x1 is 7 plus 9 divided by 2, I got an 8. So I'm replacing this 8 here. So I'm going to replace 8 here, students. Okay, I need some space even. Into 8. Let me check. Yeah. So now I'm going to type it, students. Exponential to power in the bracket I'm writing here 2 plus, again exponential, again its power negative 0.2 and times to 8. Close bracket, and then I am writing negative 1. So my first answer is turned to be what, students? So x2 becomes 8.0421. He said 4 dp. Now first I plug in 1, now I plug in 2. So we'll plug in 2 here and 2 here, student. The equation will turn x3 exponential. Okay, I think I should save my time and I copy paste this whole expression. So copy and pasting here. Okay, students. Now I just write it 3 here and 3 here, and this number replace x3, x3, and this complete value will come here. So that is why 8.0421. So if I replace here 8, the first previous 8.0421. So I'm getting, students, 8.0269. I think point is clear. Now plug in 3. So every value 3. So when I put 3, students, what I will get? I'll get x4 now. Here 4 and here 4. And here I'm replacing it by what? I'm replacing by its value, and value I'm writing this completely here. So 8.0269. So 8.0269. Okay, and my answer is coming 8.0324. Check it. We have to write 2 dp, students. Is 2 dp start matching? Somehow I'm not sure about it. Let's go one more attempt. And one more attempt. Let me check it once again. More attempt. So I erase this one. I erase this one. And I have 5. I've got a 5 here. And 8.0324. So when I replace here 0324, so I'm getting, student, 8.0298. Okay, now I think we check one more attempt. I think it's gradually this number is increasing, you see. So it means we can say same time. So 8.03. So 8.03 is our final answer. So 8 because he said that 2 dp, that is why. And I hope so the concept of the question is completely clear. Question number 6, students, the topic here, differentiation, A part. He's asking what, students, here, the point of minimum is M here. You can see M. And he's saying that find X coordinate of M and make sure lies between what? Lies between pi by 2 and 3 pi by 4. It means it is somewhere here after pi by 2. Okay. And do you know what is the 3 pi by 4, student? I just tell you. 1 pi by 4 is this, second pi by 4 is there, and this third pi by 4. So 1 pi by 4, second, third. So it means the answer must lies in this. So let's try to find it. It means when you differentiate, if we get a first answer, we'll ignore, because when we put derivative 0, so we get a this answer and this answer. So first answer we ignore, I will take second answer. So let's try to do it. So, so step number 1. I will start differentiating directly. Product formula, sine 2x copy, students. And differentiation of the second function. And that is, okay, here. And then reverse, and 1 plus sine double x copy. And the differentiation of second function. So this copy and this derivative inside, 1 has a 0. And sine has a cos double x into 2. Don't forget into 2, students. And this derivative is cos double x into 2. Okay, student, I'm going to put derivative 0, but important part here, we have a two main problems. Here double x, here's the double x. Oh, sorry, go all double x. So alhamdulillah is easy then. If one double, one single, then troubles. Okay, now I'm going to, this is done. No, sorry. Do sine and cos double also we have. 2 sine double x, cos double x. What about the other part? I'm getting here, I think so we can take common first of all. Common make question easier. Otherwise, a little bit complicated. So I did not multiply this inside. No, not at all. So from this part and from this part, what is common? We can see clearly cos double x common, and 2 also. So 2 cos double x common. What left from here? Sine double x left from here. And from there, 1 plus sine double x left from here. Okay, now either 0. So either this part equal to 0 or the whole part equal to 0. Okay, cos 0, I think cos double x is equal to 0. It is not possible. Why not possible? Because cos 0 always up and down. So cos 0. So basically cos 0 is a pi by 2 and 3 pi by 2. So this all crossing the boundary. Okay, even we get it, this pi by 4 is first quadrant. It's not in the range. So out of range. So we're getting the other part. We're getting here 2 sine double x plus 1 equal to 0. And sine double x is equal to negative half. Okay. Negative half, students. Okay, now we have, we can check it. Sine negative where, students? Sine negative is here. Sorry. Sine negative is here and here. So now check it. For a while, I'll take this alpha. Alpha is equal to sine inverse. Don't take a negative sign. And degree, I think it's degree or degree, I think. Degree? No, radian, sorry. So radian. So this is coming 30 degree and radian is pi by 6. So we are getting here pi by 6. Okay. So pi by 6 is this one. So pi by 6 I'm writing here, and pi by 6 I'm writing here. So my first answer, student, is this, and second answer is this. As I said before, no need to waste your time in finding the first answer. So we'll go for second answer. And what is second answer? This 2x comes down back. Okay. So I'm getting 2x equal to full circle is 2 pi. So 2 pi minus pi by 6. So 12 minus 1, 11, 12 minus 1, 11 pi by 6. Okay, 11 pi by 6. And this 2x here. We can check even first part. Just a minute. Okay, so first angle is what? Pi plus pi by 6. Okay, and this is coming with a 7 pi by 6. And now divide by 2. So we got a 7 pi by 12 and 11 pi by 12. Now, basically, actually, what happened? So, this is the first our answer. Our first answer is coming from here. How come? Just look at here, 2x equal to pi by 2. So this is becoming pi by 4. So this is my first answer. So basically, this is a pi by 4. This is the first answer, pi by 4, and this is the second answer. So second, it means this is my first answer, and this is the second answer, and the third answer. So we have to ignore first answer, as I said before. So we got this answer, okay, and we have to find the y coordinate. Let me check. Now he said find an x coordinate and find the exact coordinates of m. So we have to find out both. So how to plug in this 7 pi by 12, plug in a top equation here. So I'm going to plug in a top equation, students. So let me check it. 7 pi by 12, 7 pi by 12, 7 pi by 12. So y is equals to sine 2 times 2, 7 pi by 12. In the bracket 1 plus sine 2 times 2, 7 pi by 12. So this is becomes sine 7 pi by 6. And now I'm typing same here. Let me check 7 pi by 6. Okay, student, let me type it in calculator. And hold on. I have another easy way as well. What is easy way? Sine double x is negative half. So I can replace sine double x, remove and negative half. This saved our time better. So I think I can go for this is also right, not wrong, but I will go for easy way now. What is easy way, students? Easy way is if I copy the full question here, sine double x, 1 plus sine double x. So I'm replacing negative half in the place of double x, negative half. So I'm replacing here negative half, students. So 1 here, negative half. So this negative half outside here, 2 LCM. I got 2 minus 1. And I'm getting here, students, finally I got y is equals to negative 104. So I'm writing finally answer here. X is 7 pi by 12 and negative 104. I hope so. The point is very clear. And this is done, students. And let's go for the area part. Area part, find exact area of the region R. So for that reason, I need a equation. An equation is given on the top. And student, I have to plug in this is 0, why 0 here? Because we're looking for the shaded area. And we have a starting point 0, ending point is this one. And here I will plug in y0. So let's have a look now how we can do this next part. So let's start, student. First of all, I'm put y0. So put y0. When I put y0, students, so I'm getting here sine double x into 1 plus sine double x is equal to 0. Either first sine double x is 0 or this is 0. Okay, so now student will check it. What is the possible value? Sine 0 is where, students? You know it very well. Sine 0 is 0 and pi. And sine negative 1 is where, students? So it means sine negative is below negative 1 here. So it means 2x is equal to 3 pi by 2. And here I can say 2x equal to pi. And here I'm getting pi by 2. And here I'm getting here 3 pi by, wait a minute, this is a 3 pi by 2. So I'm getting 3 pi by 4. And I will check it, student, which is a smaller number. You know, smaller number is, we have to check it. Which smaller number that I will take as a limit, okay? And we have to check it. And so pi by 2 is naturally, pi by 2 is where 3 pi by 4, 1 pi by 4, second pi by 4, and thread. So it means this is 3 pi by 4, and pi by 2 is smaller number. So we'll take as a pi by 2 smaller number. So that I will consider only. And now, students, I'm going to solve this integration. So how we can do it? How to get area part? Area part is, students, so 0 to pi by 2. And this complete equation I'm copying here, which I copied from here. And now, student, what to do onwards? I will multiply inside 0 to pi by 2. So I'm getting sine double x and plus sine double x square. Students, you know integration of sine double x is very easy available, but this is not available directly. So for that reason, we have to know this formula, and formula is here. If you remember, cos double x equals to 1 minus 2 sine single x. And what's the rule? Half angle comes here. So that is why if we need a cos 4x here, students, I must get 2 sine square double x because half angle here. And I need to make this subject. If I make a subject, so this will go there, and this will go there, and 4 will go on the side. I show you directly. So sine square double x is becoming 1 minus cos 4x and divide by 2, which I'm going to replace now here. If I'm placing here, students, 1 minus cos 4x divide by 2 dx and 0 to pi by 2. And I'm going to plug in the limits. So what is integration of sine negative cos? And divide by 2. And limits very clear, 0 to pi by 2. And what about this? Negative half, 1 by 2 I bring outside, make question easier. Integration of 1 is x, and cos is a sine 4x over 4. And limit 0 to pi by 2. Negative half goes outside, make question easier. And 0 to pi by 2. And this is a half as it is, and rest I'm not doing any change. Okay, or I can bring, okay, this make it easy, leave it, no need to bring out. Okay, student, best way, plug in this one. So for your information, cos pi is -1, make sure. And sine pi is 0, don't forget it. Okay, how do this one? Because when I plug in this value here, student here, so I'm getting here cos this pi, and that is 0. Sorry, that is a -1. And when I plug in 0 cos 0, and that is -1. -1. That is -1 and okay, just a minute. 3 pi by 4, 3 pi by 2. Okay. 3 pi by 4. This 2 to the 4. Okay, what about the other part? Other part is, student, I'm going to plug in here pi by 2. And when I plug in pi by 2 here, so I get here, students, this is a 4. So this is coming with us sine 2 pi, this gives you 0. I plug in 0 now. So I'm getting from here, sorry. I'm getting from here, wait a minute, students. So this is, student, we're getting pi by 4 from here. And this is a cos 0 is 1 basically, not -1. This is my mistake. I wrote -1 because cos 0 is 1. Okay, student, this negative half outside, inside I got a -2. And negative positive 2 to cancel. I got a 1 from here. So 1 plus pi by 4 and unit square. We got an area. I hope so. The concept of question is completely clear. Question number 7, students, and this is a partial fraction. We have to do it. Always, whenever you start this kind of question, check if the highest power up is x square. And highest power down, x square into x, is x cube. If upper power is smaller than down, this is called proper fraction. If it's improper fraction, then you must go for long division. But here, no need. Okay. So I can do directly. And what is the way of writing direct? 5x square plus 8x plus 5 over 1 plus 2x and 2 plus x square is equals to a over linear factor because power 1. Whenever power 1 come of x is called linear factor, but here is not linear factor. Here we have power 2. You can see power 2. So you can't write b only, no, wrong. bx plus c. Okay, now I'm going to multiply whole equation with the left-hand side denominator. So when I multiply here, I will get a 5x to power 2 plus 8x and plus 5. And when I multiply with this will cancel with this, and with a, I will get 2 plus x square. And when this multiply with this, This cancel with this, and we get it bx plus c and 1 plus 2x. Here's one technical mistake. So some students don't put a bracket around it. Wrong. You are must, look, I show blue color so you can understand. This bracket is must. Okay, clear. Now student, one time, this linear factor, I will plug in equal to 0, linear factor, and I got x is equals to negative half. Replace whole equation with the negative half. Though we have another method also, but that is a comparison method, comparing equations, compare coefficients. But I'm going to plug in this way. So let's see now what happens. When I plug in this half here, so I get a 5 over 4. When I plug in half here, I get a negative 4 plus 5. When I plug in half here, so I'm getting in the bracket 2 plus 1 over 4. And because this is 0 already I said before, so no need to waste time here. And students, now I'm going to check it. 5 divided by 4 and plus 1. And divided by what? We got a left-hand side, what students? 9 over 4. And 2 4s are 8. Here I got also 9 over 4. And if we check it, the answer is coming with from 1 here 1. So A value is coming with here 1. Now students, I have done it. Now I'm going to plug in any other number, but I can't plug in this equal to 0. Why? Look, I'm going to show you here. If I plug in this equal to 0, students, so it becomes negative 2 and it becomes like a root negative, which is not possible. So that is why I plug in after this number, I plug in best number is 0. Whole equation 0. Everywhere, every x 0. So left hand side, I get a 5 students. And I got here 2 plus 0. And here I got a 0 plus c. And here I got a 1. So finally, I got a equal to 2a and c. And a value comes from the top. This value will come here. So 5 is equal to 2 and plus c. And c value is coming with us is 3. All right. And now students, I can plug in any number. Okay, I think best second ideal number is 1. So when I place 1 in a whole equation, I get a 5 plus 5, 10, and plus 8, 18. When I plug in 1 here, 1 square, 1 plus 2, 3a. And when I plug in 1 in each x value, I'm getting here b plus c, and I'm getting 3 here. So I'm going to replace a value, students. A value is 3, 1s are 3, and b I don't know, but c I have it. So 18 minus 3 is equals to 3 times 2, 3b and plus 9. And I'm getting here 15. So from 15, subtract 9 and divide by 3. I got a 2. So b value is coming with us 2. And I'm going to plug in all values back in this equation. And I'm going to plug in back all values here, students. Check it. Okay, 1 by 1, erase A. Its value is 1. Then erase B. This value is 2. Then erase C. Its value is 3. I hope so this clear, students. And this value, okay, let's check it. What is the next part we have? Next part we have is find the coefficient of x cube in expansion. So we have to apply binomial. So we are bound to take this on the next page. Okay, so I'm copying here. So little bit hard to start from here. Reason, whenever we have to apply binomial expansion, we need 1. And formula I'm writing on the top. Okay, formula, okay, I'm writing down, no problem at all here. 1 plus b and power n. So 1 plus nb and then n into n minus 1 over 2 factorial into square of b. And then n into n minus 1, n minus 2 over 3 factorial and cube of b. So student is only applicable if we have a here plus 1. So do you have a plus 1 available? Correct. So here no, but do you have available here? No. So that is important to make it. So let's try to make it first, students. I will take 2 common out. So 1 plus x square by 2 and 2x plus 3 available on top. And student, one more shape, then I'm going to apply what shape I have to give. This will go up. So 1 by 2 times 2x plus 3 and 1 plus x over 2 to power negative 1. I call this equation number 1. And now students, I'm going to apply formula. And get ready, I will apply it 2 times. Keep our eye on target, and that is x cubed. So, oh, sorry, I have to bring this up also. Here I'm getting 1 plus 2x into power negative 1. So 1 by 1 I will do, students. So first I talk about this. So when I talk about this, 1 plus 2x to power negative 1. So formula is 1 plus nb. Then n into n minus 1 over 2 factorial into square of b. Then n into n minus 1, n minus 2 over 3 factorial into cube. So I'm getting 1 minus 2x, students, and this is fully cancelled. And I'm getting here 4x to power 2. And this is what, student, this cancel give us minus 1. Okay, minus 3, minus 2, yes, minus 1. So I'm getting here negative 8x to power 3. So first expansion, student, done. Now I'm going to do second one. So second one, I'm going to copy complete. Lot of patience required, student, this kind of question. Okay, now because thing is important, do we need to expand all 3 terms? Not at all, because power is 2 inside already. Let's see, half times 2, 2x plus 3, and I'm applying 1 plus nb. N is a power and b is inside. nb, 1 plus nb, and stop here. You may ask why, sir? Because if I apply square of the square become 4, and 4 is not required, so I will not waste time here. And we're getting 1 minus x square over 2. And we have to simplify now. And we are going to get our answer. Okay, both values I'm going to plug in on top equation. But first of all, multiply better. So when I multiply, student, what happens to then check it? In the bracket, 2x into 1, I got 2x. And 2 to cancel, I got x cubed, then 3, and then 3x square over 2. Half goes inside, I get finally x from here. Write in okay, that x here minus half x cube plus 3 over 2 and minus 3 over 4 x to power 2. Now this is done, student. Now I'm going to combine them because this value will go here and that value will go here and just add them. So I'm saying put in 1. So 1 by 1, I'm going to do it. This value I'm pasting here. Okay, and this value, and in the middle, I'm putting put a plus sign. Now, students, let's start. And how we can do now? Like a numbers. We have to just numbers with numbers. And for example, this one with 3 by 2. So if I add 1 plus 3 by 2 is give you 5 by 2. So 5 by 2 comes from here, students. After this, what is next? We have x values. X values, there are 2 x values, students. There's a positive x and there's negative. So I get here negative x. And then x square, students, x square, we have this and this. So 4 minus 3 over 4. We are getting here positive 13 over 4 x square. And last number minus 8 and minus 1 over 2. Okay. And we are getting here negative 17 over 2 x to power 3. So, so once again, okay. And I hope so the concept of question is very clear. Your student final is here because we are looking for x cube here, x cube coefficient, and that is why we have to write only x cube coefficient. So coefficient of x cube, and that is negative 17/2. And I hope so. The concept of question is completely clear. Question number 8, students, given that this z is given and y is a real number, express 1 by z in this form. Okay, and we have to express that. So first of all, I'm writing here 1 over z. So it naturally is becoming 1 over 1 plus y iota. Okay. Now how to solve it? Rationalize. Naturally, you know it very well. 1 minus y iota over 1 minus y iota. So I'm getting 1 minus y iota and 1 square minus y iota whole square. 1 minus y iota over square of 1 and here square of y square into minus 1. And then I can form it 1 minus y iota over 1 plus y square. And if we check it, students, because we have to give in a complex form, so real part by real part, imaginary by imaginary. So real by this and imaginary component by this. So I can say that I can write 1 over 1 plus y square and positive negative y over 1 plus y square iota. So I think this part is clear, students, and we have done it. And he was asking to convert that form. So first part is completely over. Second part, he is asking show this expression is equal to 104. Okay, students, and he said a and b are functions y found in this one. So it means basically this is equals to a and this is equal to b. I have two options, students. One option, if I replace that, or second option. Second option is what, students? I can plug in the values, because this is a value of a, you know it very well. Okay, so this value I'm going to replace here, and this is a b value, and I'm going to replace here, and I'm going to solve. Okay, so let's start. So here I'm writing 1 plus y to power 2 negative 1 over 2 whole square. And let me check again. Yeah, correct. And b is basically this one. So I'm writing now negative y over 1 plus y square and a whole square. And I have to prove equal to 1 by 4. So student, what is the technique here? I will apply squaring identity or take LCM. Both are correct. Okay, students. I think I take LCM first of all. Better. 2 LCM 1 plus y square. Okay, this multiply with and this multiply there. So I can say 2 minus 1 minus y square. I think ultimately we have to go for LCM even. So why not we can apply, so squaring identity. Why not we can apply directly squaring identity. So squaring identity is very clear. You know it very well. So first term square, negative 2 into first term into second term plus second term square. And this is clear already. So this will come in first two brackets. So I'm writing 1 over 1 plus y square and 1 over 1 plus y square. And this go in next two brackets, 1 by 2 and 1 by 2. So I'm getting here 1 over 1 plus y square whole square. And 2 cancel out. I got a 1 over 1 plus y square. And here I got plus 1 over 4. This is done, student. What about this? So square of y over 1 plus y square whole square. So this again I'm writing here. And now we will go for LCM of the whole, and then inshallah we get our answer. LCM of whole equation is what, students? So LCM of whole equation is, you know, power 2, power 1, and 4. So LCM is 4 and 1 plus y to power 2 and power 2. What is difference? What is the lackness here? This is match. So what is missing? 4 missing. So 4 multiply up. You can say 4 multiply up and down, that sense. So I got a 4 here. What is missing here, students? So 1 power match, one power missing, and 4 also missing down. So I can say I'll get a 4 times to 1 plus y square. And what is missing here, students? This is a 4 present, but this total missing. So I'm writing here 1 plus y to power 2 and square. And this fully match, so 4 will multiply on top. So I can say 4y to power 2. Now, students, I'm going to further what we can do here. Down part, I'm leaving as it is. Open the bracket, I get a 4 minus 4y square. Here square open, I'm getting, or I think leave it open. I just leave as it is, no problem. And there's a 4y to power 2. So this cancel with this and this cancel with this. And we are getting 1 plus y to power 2 whole square over 4 times to 1 power 2 whole square, and they cancel out. And we got 104, proved. I hope so the concept is clear. Though we have another way also, if we assume this equals to A and this equals to B, then we can replace there, we can get the second method as well. But I think this is I have done directly, no problem. Let's go for next question. Next part is that on a single argon diagram, sketch the loci given by equation this and this. Okay, let's start first of all. Do you know when our modulus come one side and second side a number is representing circle, which I'm writing now here. I'm introducing here 0 plus half. Oh, sorry, this is a real part. Sorry, real part. So I'm writing here half plus 0 iota. And equal to half. Equals to half. Okay, what is this called? Center of circle, students? All of you familiar? And what this called? Radius of circle. So it means I will make a circle. First, I make a circle, and okay. Okay, and center is what, students? It is a y0 means as on x-axis. So I will make a x-axis. Okay, this is done, students. And now I can guess from here, what is the radius? What is the radius, students? We can see a half. It means this distance is a half and this distance is half. And the center is also, we can see half and 0. So 100% the y-axis is here. Okay, this is done, students. Okay, now what is the next plan? Is and I mentioned here this is an imaginary axis, and there's a real axis. Okay, and this is the radius is very clear. We can see from here half here, even half. Okay, and now I talk about this one. So real of z. Before I start, I just tell you one thing. This is a imaginary axis. We can call as an imaginary axis. You know it very well. But formula is as real of z is equal to 0. Real of z is equal to 0. Okay, similarly, this is imaginary of z is equal to 0. So what about this, student? If local line goes for 1 and 2, this is called real of z is equal to 2. So he's saying, make it this one. Real of z is 1. So I will make a line which is going through here. I'm going to make a line here. There's a line. So, and I'm writing now here, even on the line here, this I'm writing real of z is equals to 1. And we have done it. And he said on single diagram, sketch the loci of this and this both together. That's it. We have done it, student. Now, last part of question. Complex number z such that real of z is 1. Okay. And use your answer in part B to give a geometrical description of the locus of 1 by z. So basically, you know, students, 1 by z, if I go back and check it, I go back and check it. Look at now, students. If complex number is this, then z is this format. And, you know, and then we can say this is this x and y, okay? And and even we can see here that this value is this equation is becoming a equation of circle. You know, students, look at now. If I show you, if I shift this on the other page by keeping x and y, and I'm writing here not 4, I'm writing 2 square. Basically, this equation of circle. If you look at carefully, students, so cut from here and paste and bring other page. So this is basically is a equation of circle. You know it very well. And radius is coming from here is very clear, half. So radius is coming from here, half. And that he's asking that what is geometrical representation. So we can say that this is a radius is a circle, the circle equation with center, yeah, here we can write 0. Okay, here we can write 0. So check it, minus 0 whole square. So center is a half from here and 0 from here. So I'm getting half 0. And the radius is half. So this is called geometrical explanation. I hope so. The point of the question is very, very clear. Question number 9, student, we have position vector of A relative to origin is this. And L passes through A and parallel. So this is called direction, students. So this is called direction. So what is formula, students? R is equal to A plus lambda times 2B. The B is this basically, and A is a point. So we can get indirectly one step answer, 8 minus 5 and 6, and 2, 1, and 4. Okay, this is done. State a vector equation line, 2 marks done. Next part. Let me check finally 2, 1, and 4, 8. Yeah, correct. Okay. Well, second part. Position vector of B relative to O is this, and the line passes through B. It means line is given and B lies on it. When B lies on it, so I can first of all convert standard form, students. What is standard form? Lambda multiply inside and add these values. I got 8 plus 2 lambda and negative 5 plus lambda and 6 plus 4 lambda. Basically, when I say that this point lies on it, so it means the x component of this point is equal to x component, and y component of this b is equal to y component, and z component equal to that. So I'm going to make 3 equations. 8 plus 2 lambda is equals to negative t. I got from here. Second equation, I'm getting here negative 5 plus lambda equal to 4t. And third one, 6 plus 4 lambda. 6 plus 4 lambda is equals to 3t. Now I have to solve them simultaneously and get the t value. And that's it. I think so. So how I can, which equation is more suitable to solve? All are okay. If I multiply this into negative 2 and add this, we can get it easily. So I'm solving 8 plus 2 lambda is equal to negative 2, and this equation multiply with negative 2. So I'm getting negative 2 means 10, negative 2 lambda and equal to negative 8t. Okay, so negative 8t. This clear. So after this, student, what to do? This cancel out. I got 18 and I got negative 90. And t value is becoming from here is coming with us negative 2. So I hope so. The concept of question is very, very clear. And even I solve the other two, we get the same answer, not a problem. So C part he's saying here, the line L is what we have already, students, and line M is given here. The acute angle between the L direction and M is theta. And we have given this form, this value even. Basically, two lines intersecting, line L and line M. And this angle between them is this, and cos theta is given. So students, you know, whenever we find the angle between the lines, we always take the direction. What is direction? After lambda or mu is called direction. This is called B1, B2. Okay, from the previous page, I will take the direction as well. And direction we have here is after lambda is this is called direction. So 214, 214. I take from here 214. Okay, so 214. I call B1 as a 214. and B2 I take from the top here, which is a negative 1, 3 I took from here. So student, let's start. Formula is what? B1 dot B2 equal to B1 magnitude into B2 magnitude into cos of the angle between them. So I'm putting the values 214 and A minus 1, 3. The magnitude of B1 is what? Square all and add them. Like a 2 square 4, 1 square 1, and 4 square 16. Same to here. A square is A square plus 1 and plus 9. Into cos theta replaced by 1 over root 6. Is completely replaced by 1 over root 6. I think clear idea. So possible values we are looking for. So students, this is a dot product with corresponding position values we multiply. So I got here 2a negative 1 and plus 12. Here I got 21 root. Here I got a square plus 10. And here I'm getting root 26. Okay. Okay, students, what is the technique now? We have a 2a and this is a plus 11. And what is here two roots can be combined even. So I can write to like this 21 over 6. And inside we have this one a square plus 10. I can cancel these numbers 3 twos are and 3 7 times. I'm getting 2a plus 11 is equals to 7 over 2 root and root of a square plus 10. I can do one thing, squaring both sides. So when square left side, I will get this kind of value. And square this for 7 over 2 root cancel, and here also root cancel. So here squaring identity for first term square, second term. Okay, look, I show first step by step. So first term square plus 2 into first term into second term plus second term square. And 7 over 2 or a square plus 10. So here 2a, here 2a, here 11, here 11. So I got a 4a to power 2 and here 44a, here 121. And now 2, this 7 multiply inside 7a square and plus 70 and 2 going to multiply left hand side. This 2 multiplies here. So I'm getting here 8a square and 88a and 242 and this all values going to come left side. And these two values will give us a square, okay, and plus 88a, okay, and this one is 242 and minus 70. 242 minus 70, I'm getting plus 172. So I think up till here, students, idea is very clear. And we have equation, we got this equation. Now, students, for onwards, common sense, we can apply only quadratic formula and get the answer. So I'm doing in quick time, negative b plus and minus b square minus 4, a is 1, c is 172 over 2a. And one time just show this and give direct answer, no problem at all. Using your calculator and you can get answers. So two answers which I'm getting from my calculator is coming with me negative 88, 88, okay, ABC value, and I'm getting negative 2 and negative 86. And I hope so the concept is very clear and we have done this question complete. Question number 10, students, we have, and a large cylindrical tank is used for store water. Okay, the base of tank is circle of radius 4. And at time t minutes, the depth of water tank is h meters. You can see. Okay, and tap is bottom of the tank. Okay, when tap is open, the water flows out of the tank and rate proportional to the square root of the volume. Let me write again. Water is flowing, so it means d volume by dt is proportional to what he said. And because water is flowing out, leaking, so I must write negative sign. Okay, the square root of the volume of water. So square root of the volume of water. I think this part is clear, and now we have to complete further. So first of all, I'm writing this one. So then remove the proportion sign. So we always get a constant of proportionality, I think this part is clear. But we have to prove this link. And you know, student, here height and time and here volume. Whenever more than two variables, so volume, height, and t, more than two variables involved, we always use chain rule formula. So what is chain and how to start chain rule formula? What is the target to achieve? Start from there. So I'm writing here by chain rule. So when I start by chain rule, students, what is my job to prove? So dh by dt. I write two fractions, students. So this will come in first numerator and this will go in second denominator. And third variable is volume. So dv and dv. So this student, we have it already, so no problem at all. But problem from where I will get h over v. So that reason I have to connect the wall height, okay, and volume of cylinder. So because volume and h together, that is why volume and height. So you know, students, volume of cylinder formula is pi r square into h. Basically, formula is base area into height. And base area is circle area formula is pi r square into h. So I think it's very clear. So dv over dh, pi is constant, and you know r is fixed. R is not changing. So I'm r fixed now, and height becomes 1 because I'm differentiating with respect to h. So h derivative become 1. So I'm getting d. This is clear, and now I can plug in this, but it's reciprocal, students. So when I do reciprocal, dh up and dv down, so I get a 1 over pi r square, and r is what, students? 4. So I can plug in here 16 pi. So this value I get from the there, and I'm writing here 1 over 16 pi. And this value I get from the there, I get a negative k times 2v. And what is the v, students? Volume of that is very clear. You know, it is because we have to prove in the height involved. So no v required. So what is the volume formula? You know it very well, pi r square into h. So I'm going to replace inside pi r square into h. So student, let's try to do it. Now we have to match that form, that lambda value. So let's see now what we can do. Negative comes out, k come on top, 16 and pi comes here, and I can r power 2 will cancel out, will go out. But root pi stay inside and root h stay inside and r comes outside. Okay, r comes outside and r value is, you know very well, is a 4. Radius value is given as 4. So which I can replace, and this is replaced by, yeah, we can replace r value because r is a fixed value given here. So this I'm replacing here 4. So this 4 here, and now student, this 4 cancel out and we got this, and then final form I'm going to give you negative k root pi over 4 pi and times 2 root of h. So you can see now we are close to prove our answer, and it's a complete value, sorry, without negative sign, complete value will take is equal to lambda. And I'm writing now, and okay, this is, we can write leave as it is form or root together even, no, sorry, pi together even, no problem at all. So both are acceptable, and I'm writing there k times 2 root pi over 4 pi and is equals to lambda. So if I keep lambda, so dh by dt is equals to negative lambda times 2 root h. I hope so. Point is very clear, students, and we have proved. And lambda is a positive constant. Okay. Here we can leave even, or we can rationalize. Mostly we write root in a numerator, but if we need a denominator, we want to make a 1 root. So how we can do it, student? Check it. So root pi over 4 pi and multiply up and down root pi and root pi. Rationalize and rationalize k and root pi give you pi, students, and down I got a 4 pi and root pi. This cancel out. So we got a new formula and k over 4 root pi. So both are okay. You use the upper one or the lower one. Both are correct. I hope so. The concept of the question, the first part is very, very clear. Part. And student, what's B part we have? He's saying here at time t0, the tap is opened. Okay. and the h is 4 and time is 0. So one parameter is given and we have given another parameter. So h is this and t is this. So we have given basically two parameters. Okay, students. So solve differential equations to get t in terms of h. So our main job is to make a t subject. And last time we said find the time when the tank is empty. So it means I have to plug in last attempt h is equals to 0. Logic, because empty tank means height is 0. So that is the last attempt. So let's go back and bring the expression. Expression, we just prove it. This one expression we have proved. And we are bringing here. Okay, this I'm starting now. So let's start, students. First of all, you know very well cross multiply. So I will get what here? dh negative lambda times 2 dh and dt goes there. So this both values will go at left side, okay? Because we have to do what? Bring it down here. So full will bring it down. So I can say I got a negative 1 over lambda and dh also, sorry, root h into dh. So basically I brought complete down here, okay? And but can I integrate directly? No way. H to power negative half and dh. Now question is ready for integration. So I'm saying integrating both sides. So I'm getting dt here. Negative 1 over lambda is constant. I can bring outside h to power negative half t dh, sorry. And I'm writing now here is a 1. So t from here and negative 1 over lambda. And here I gotta increase the power by 1 and divide by same. Plus c. So I'm getting, students, t is equals to negative, this flip up, and we got a negative 2 by lambda and root of h and plus c. Now we have parameter, students, given. What's parameter number 1? h4t0, h4t0. So plug in h4t0, h4 and t0. Let me check again. Yeah, h4t0. So when I plug in t0 here, student, negative 2 by lambda and root of 4 plus c. So if we check it, I got a root this. So c value is becoming, this is a 2 to the 4 and 4 over lambda. I'm getting 4 over lambda. And this I'm going to plug in back in equation. So when I plug in back in equation, students, what I get, t is equals to negative 2 over lambda root h and plus 4 over lambda. This is done. And yeah, now put second equation. Second equation, what we have, students? So this one, 2.25 and 20. 2.25 and 20. 20. So I'm going to plug in this now and get the lambda value. So first of all, I'm putting 20 in the place of t and negative 2 over lambda and root of 2.25 and 4 over lambda. And now we check it in calculator. Basically 2.25 is a 1.5. Root of 2.5 is a 1.5 and 1.5 into 2, I get a 3. So this will give us 3. This will give us 3. So 20 is equal to negative 3. Negative 3, let me check again. 2 times 2, 1.5 is giving 3 over lambda and plus 4 over lambda. And take LCM lambda, 20 is equals to, I got a lambda LCM, I got a minus 3 plus 4, and lambda value is coming 20. So lambda is 20, student, and this is this value 1 over 20, sorry. Okay, student, this is a clear. And because lambda goes, this is a 1 by lambda. Look at now again, once again. I got a 20 is equals to 1 by lambda. Lambda goes there and 20 comes down. So lambda is equal to 1 by 20. So I can plug in this value there, okay? And what I get final equation. So final equation, students, is giving with us is t is equals to, when I plug in 1 by 20 here, so that flips up and we get a, because 2 over, negative 2 over 1 by 20. 1 over 20. Root h and 4 over 1 by 20. it goes up, and t we're getting here negative 40 root of h. And student, what is the other end? So I got 80. So this is done. Now, student, what is asking for? We have done this expression. He's saying when because he said empty. You see your students on top, empty means h0. I'm going to plug in h0 here. So put h0. So check it when we put h0, students. So time is becoming 80. So I hope so. The concept is very clear and we have done, and the question is completely over. And the paper is completely over. And best of luck for upcoming exam. And pray for me. Assalamu alaikum wa rahmatullahi wa barakatuh.